Today's our topic is variation of G with the speed of rotation of the Earth. Yesterday we had done the variation of G with altitude and with the depth. Today we are doing, as I told yesterday only, that the value of G varies with the speed of rotation of the Earth. Let us see how it varies. So we draw a diagram first. We take like this is Earth, center of the Earth is here. This is the axis of the Earth, axis of rotation, and Earth is rotating. Suppose we are having a point or place A situated here, making an angle, that is this angle, lambda. Latitude value is lambda there. So rotation will take place like this. What is own axis this way. Let us suppose this radius is r and the radius of the Earth is capital R. So weight will be acting there towards the center. Weight of the body is acting this side, and out here the centripetal force will be acting like this. Centrifugal force acting away, that is F is equal to centrifugal force formula like mv squared by r, but mv will change in terms of omega, and v squared omega squared by r will cancel, this become m omega squared, is acting like this. So this F will break into two components, one component here, one component will come here. This angle is lambda, this angle will also become lambda. The value of this component is coming m omega squared r, this value, and this will cos alpha. This will come m omega squared r sin alpha. What is the net weight? We have here, therefore, net weight of the body, net weight of the body net weight of the body W is equal to, we like this actual weight, that is mg, minus this component, minus m omega squared r cos lambda. Net weight, let us add mg dash mu with the new value of gravity there. Take m common, here it will become g minus omega squared r cos lambda. M will cancel. You get g dash value coming as g minus omega square. We use the formula of cos r, cos lambda formula there. This is lambda, so this angle will become lambda. In this triangle, cos lambda will be equal to base by hypotenuse, that is r by capital R. That is small r, we can write r cos lambda. Let us write r cos lambda, and already cos lambda is coming, become cos square lambda. So we have the formula coming, g is equal to g minus, this is the formula, this becomes the formula, this one. This is the new value of g at that point, at a latitude due to speed of rotation. The formula becomes g minus omega squared r cos squared lambda, where r is the radius of the Earth and lambda is the value of this latitude. Okay, now we write here at poles lambda value will be how much? It will be 90 degree. When the point is situated or the place is situated here at the pole, the angle lambda value will be exactly 90 degree. Then g dash value will come g minus omega squared r cos squared 90 degree. Cos 90 is 0, the entire thing becomes 0. That means g dash value will be g. There is no variation takes place, no variation at the poles, no variation at the poles. The value of g does not vary at the poles, and it is the value is maximum, that is 9.8 at the poles. Okay, now we see at the equator. At the equator lambda value is 0 degree. Therefore g dash value will come like this, g minus omega squared r cos square 0. Cos square 0 is 1, function remains this. So at equator we will have the minimum value. Though all those places are situated on the surface of the Earth, yet the value of g will differ. The value of g is maximum at the pole, and the value is equal to 9.8. That is g value 9.8, and minimum at the equator, and this value will be calculated. That means g depends upon the speed of rotation of the Earth, omega value. Omega we have to calculate, we can do 2 pi by t. 2 pi by t is the time period. What is the period of rotation of the earth? 24 hours. So we know the value of omega and we know the radius of the earth. Accordingly, we can calculate the new value of g. So derivation of this formula is not in the syllabus. Only you have to know the result. This result you have to know, and you have to see this conclusion that the value of g does not vary at the poles, and it is minimum at the equator and maximum at the pole. And what is that maximum value? Equal to g, the normal value, that is 9.8, the maximum value. If question comes like this, what happens to the value of g when the speed of rotation of the earth is increased? When we increase the value of omega, so what will happen to the value of g? We say the value of g decreases, because minus this part it will decrease by a greater value. But we have to write except at the poles. Except at the poles. Because at the pole, no matter how much speed how much speed the earth will have, speed of rotation, but lambda is 90 degree, then entire field, this part will become 0, then there will be no variation at the poles. Variation does not take place at the pole. So we write the answer like this: when the value of g, when the speed of rotation of the earth is increased, the value of g decreases, but except at the poles where it remains the same, where it does not vary. We must mention that. I think this topic is done. Now, next topic we are doing is gravitational potential energy. Gravitational potential energy. Gravitational potential energy, that is denoted by the symbol capital U. Capital U. In class 10 and all, used to learn the formula potential energy is equal to mgh, but now the formula will be slightly different. We will be drawing a figure out here like this. There is the center of the earth and bodies lying on the surface of the earth. This is R out here. And lower class we used to take the potential energy at the surface of the earth. On the ground level we used to take 0, and when the body used to go from the surface of the earth we used to take mgh. But now if the point is situated on the surface of the earth, it is of course at some height from with respect to the center of the earth, so it will definitely have potential energy. Actually all are having same kind of potential energy, so that only we consider as the origin. That is our starting level. From there only we are comparing the energy of everything, but still it has potential energy. Potential energy is not zero. It will have definitely some potential energy. We are finding that only. That U is equal to, that is potential, gravitational potential energy U is equal to any kind of energy we measure by the work done capacity. We write here force of gravity into the displacement. Into the displacement, we write that into the displacement. Force of gravity is acted towards the center. That means that is called mg. There is force of gravitation between this mass and this mass. I take m. So force of gravity formula I get here mg by r squared. And that is acting in which direction? Downward, that is this way towards the center. But displacement, how are we measuring displacement of this body from the center is coming this way. Displacement we are measuring in terms of OA, that is minus R. This R cancelled, the formula becomes minus G M by R. This is the formula of gravitational potential energy. Gravitational potential energy formula Q is equal to minus G M by R. Here minus sign indicates that the body is attracted towards the center of the earth. The body is in the state of attraction. It is attracted by the earth. That's the minus sign comes here. Capital M is the mass of the earth and small m is the mass of the body, whose potential energy we are finding on the surface of the earth. And R is the radius of the earth. Now, next topic is escape velocity. Escape velocity. escape velocity. Escape velocity. What is escape velocity? The velocity of a body at the surface of the earth, so that the body goes out of gravitational pull, is called the escape velocity. If you give some velocity to the body so that it does not return back to the earth's surface, it goes out of the gravitational pull, out of the gravity. There's such a velocity given to the body is called escape velocity. And we find a formula for escape velocity. Escape velocity formula we find by using the energy consideration. The body is from the surface of the earth is sent and it's not returning back. So we can draw a diagram here like this. Here is the body A. The radius of the earth is O like this, and it is going and infinity. We don't know where it is going. So we will be writing a total energy at A is equal to, this is the infinity point, we write a total energy at B. This point is supposed B at infinity height. We don't know which height. The total energy, what energy it will have? It will have potential energy. We write the potential energy formula at G M by R with the negative sign, plus kinetic energy because we are providing it some velocity at half mv square. Velocity to this mass, that is small m, and capital M is the mass of the earth. Total energy at B is 0 because it is escaping, so there is no energy. So that's why it is not returning back. So this minus side set the other side, it will become this half mv square is equal to G m by R. Small m will cancel. Right, half v square. Gm value will write gr square by r, because we know since g is equal to gm by r square. Therefore, gm value will become cross multiply gr square. This will cancel. Therefore, v square value will be 2gr, or v value will become root 2gr. This velocity is the escape velocity. The escape velocity, that is the body is not returning back to the surface of the earth. This is the formula of escape velocity. For the surface of the earth, if we find escape velocity, then answer we can find out like this: root 2, the value of g of the surface of the earth is 9.8. Radius of the earth is 6400 kilometers. 6400 into 10 to the power of changing in meter. Calculate the entire answer will become 11,200 meter per second. If we change in kilometer, answer will become 11.2 kilometer per second. Such a high velocity you have to give to the body so that the body will not return back. This is the value of escape velocity for the surface of the earth. That means in 1 second the body must travel a distance of 11.2 kilometers. In 1 second the body is covering a distance of 11.2 kilometers. That is almost from this place to the really Chitre, till that distance if it goes in 1 second time, then the body is surely not be able to come back, return back to the surface of the earth. So this is the value of escape velocity for the surface of the earth. And for the surface of the moon, if you have to find the surface of the moon, the value of g is very less, that is 1.6 times of the 9.8. And the radius of the earth is also very small, it is 1 by 81 times of the surface of the radius of the earth. We will put all those values, the escape velocity value will come very less. It will come very small. And due to that reason, there is no atmosphere in the moon. Because escape velocity is very low. With lesser velocity, the atmosphere, the gases and all, they all are escaping the moon's gravity. They do not stay there. The value of escape velocity for the surface of the moon is very small, and that is the reason why there is no atmosphere in the moon. So today we did till escape velocity. Tomorrow I will be talking about the satellites and then planets and the Kepler's law of motion, planetary motion. Thank you.